Now let's have a look on this second graph in this video. So what I try to do here is to plot some points based on this graph to see the relationship between total revenue and quantity demanded. And we can see by connecting the dots what the relationship is going to be. So for instance, if we look at the quantity demanded of 2, when the quantity demanded is 2, the price is 6. So the total revenue, which is equal to the price times quantity demanded, would be equals to 2 times 6, so it would belong to the point of 12. So we plot this point. Then we go along the curve and we choose, for instance, the in-between, the point of 3. Let's say this would be 3. And we go up, it would be approximately 5. At the price of 5, 3 units demanded, the revenue would be 15. So we plot this point. Then we go at 4. 4, for the price of 4, it would be a total revenue of 16. And we keep doing that for several other points to see the relationship. And when we connect the points, when we connect these points like that, we can see that the relationship is like a downward parabola. This should have looked better, but the graph is not at scale. But I guess you understand the point. The intuition is that total revenue initially increases with quantity demanded, reaches a certain peak, and then it starts falling. And that's the idea, that in the beginning we can increase price to increase total. Sorry, in the beginning we can still increase quantity demanded to increase total revenue, but we reach a peak, and afterwards, by increasing the total quantity that we're selling, we must decrease the price. But it's becoming less profitable because the total revenues are starting to fall. And if we look on our graph, then this maximizing point, maximizing total revenue would be around at the quantity of, let's say, 5 to 6. And this is not going to be exactly accurate on our graph because it should have been on this region, but 5 is somewhere on the, on the green line that I shaded. But this should have been somewhere over here on the unit elastic demand. So that this graph and this explanation here, even by using just intuition without math, makes sense. We are reaching the total revenues that are maximized when we have a unit elastic demand. And to give just 2 more cents on it, to just make sure like we actually get it, think about it this way. If here we can still increase our total revenue, by definition we're not maximizing, because maximizing means we cannot increase it anymore. So by definition, when the demand is elastic and we can still reduce our price to increase quantity demanded and to increase revenues, we're moving towards the maximum point. We're still not there. The same goes here. When we're at the inelastic demand, by increasing the price, we can still increase our total revenues. So by definition, we still have room for improvement to move towards this total revenue optimal. But at the unit elastic demand, again, by definition, we're reaching the peak of the graph where we cannot improve the total revenues anymore by any strategy. So that's why this one corresponds to the graph on the left. I hope this makes sense, and we are done.